Hi everyone. Pre-calculus 1-4 Extrema average rate of changes. So we will deal with these topics. Increasing, decreasing, constant functions. Okay. So we can say function is increasing. When you talk about increasing, decreasing, constant, one thing you have to be careful. Please trace your graph to right. You're gonna move from left to right. Then observe what happened to the y value. So as you move to the right, y value, what happened? Y value is getting increase, increase, increase. So we say increasing. So if you move to the wrong direction, which is left, you might say, well, why is it decreasing? Because you're going to wrong direction. Always x has to move to the right. So as you move to the right, what happened to the y value? Decreasing. So we say it's decreasing. Right here, as you move to the right, what happened to the y? Constant. It doesn't change, so we say constant from here to here. Okay, use the graph of the function. Say, where is it increasing, where is it decreasing? He said near to 0.5 unit. Just try to answer as accurate as possible. You don't have to worry about 0.5. So, as you move to the right, what happened? Decreasing, decreasing, decreasing. It's decreasing until here. Now it starts from increasing from here to here. So you have to answer decreasing where to where. It's decreasing from very left, wherever the very left, where is it decreasing from? Like forever to the left. So it's decreasing, 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 decreasing all the way up to here. So you have to answer in x to x value. Where to where is it decreasing? Left to forever, which is minus infinity to 0, minus infinity to 0, decreasing. Now start increasing from x value is 0 through forever to the right, which is 0 through infinity. Okay, one confusing part about this style of question is when you talk about increasing, decreasing, we're talking about y value. Y value is decreasing. Y value is increasing. When you write the answer of interval, you're writing interval of x value to x value. So this y value is decreasing. X value where to x value where. So be careful with that. Okay, use the graph. You're answering as a decreasing and increasing. So as you can see, decreasing, decreasing, decreasing up to here. So whatever that value, it's probably like 0.5, I would say. So decreasing from minus infinity left to forever. So minus infinity to 0.5, minus infinity to 0, minus 0.5, decreasing. And it start increasing from here to here. Start from increasing from here to here and start decreasing back from here to the forever. So here approximately like 0.5 x value and keep going to the right. So 0.5, which is 1.1/2, comma infinity. So here to the right, let's keep decreasing. And we have increasing from x value of minus 0.5 to 0.5, which is minus 1/2 to 1/2 is increasing. Okay, you try this, please. Pause the video, you try. So if you have looked at it, it's a decreasing, decreasing up to here. So it's not exactly -1 here. It's a little bit to the right of -1. So I would say the answer will be decreasing minus infinity to maybe minus 0.8 for example. And increasing will be from minus 0.8 through infinity. That will be correct answer precisely because since they're saying 0.5 units, so they cut it into -1. But yeah, just exact answer will be something like this. One more comment. Increasing, decreasing, constant interval, you always parentheses. Never use a bracket. Okay, relative maximum, absolute maximum, relative minimum, absolute minimum. So we call it as extrema. Relative means locally. So right here, that's a relative maximum. That's a relative maximum because they are maximum locally. They are maximum locally. Absolute maximum is the very maximum. So this is the very maximum. So we say absolute maximum. Also, it's a relative maximum as well. Same thing, relative minimum, locally minimum, that's a relative minimum. The minimum is like lowest you can go throughout everywhere. That's absolute minimum, which is this. Estimate the extrema. So basically, I'm asking you to find the maximum, relative maximum, find relative minimum. Okay. So if you look at this graph, do you see the arrow keeps going up here? So you should know there is no absolute maximum because it keeps going up. There is no absolute maximum. Same thing as a relative minimum. It keeps going down. There will be no absolute minimum either. We only have relative maximum, which is this. Okay. So maximum is what? 2. So be careful. This 1 unit is 2. So 2 comma maybe 2 comma like the 1 unit is 4 here. So maybe 2 comma 4. So we call 14. Maybe 2 comma 14 approximately. So maximum at x equal to 2. So this point will be like 2 comma probably like around 14 or so. That's just an approximation. If you want to get exact, you will have to plug it in x value is 2, x value is 2 here. You'll get exact value. I'm thinking like somewhere near 14. But the exact y value, you will get it after you plug it in. Maximum at x equal to 2. What is the maximum value? Well, 3x. I don't think they're asking x value here. I don't think they're asking actual maximum. They're asking just find what x value we have a maximum. Okay. And relative minimum, and they said x equal to -1. But if you look at it, yeah. So the 1 unit is 2, so it should be in the middle, which will be like -1. So when x equal to -1, we will have a relative minimum. So given a graph, if you estimate, you can do that. If you have a graphing calculator, you can graph it, and there is a function called minimum, maximum. You can use your graphing calculator to find the exact value. Okay, graphing calculator. Approximate to the nearest hundredth relative or absolute extrema. So if you look at it, we should have a relative maximum here, relative minimum here. So you can use graphing calculator if you have one. If you don't have one, you can use computer. There's a lot of graphing utility in Google. You can look for graphing calculator. You can graph it. You can find the maximum. You can find the minimum. You can find the minimum using graphing calculator. So if you do that, so once you do that, you can set up. So find the minimum there. They will give you x value, y value. Find the minimum there. They will give you x value, y value. Find the y maximum value. They will give you x value, y value. So minimum, maximum using calculator. Okay, average rate of change is exactly same as slope formula. Given 2 points, x1, y1, x2, y2. Well, f of x of 1 is y2. F of x2 is y2. So given x1, y1, x2, y2, average rate of change formula is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. It's exactly the same as slope formula for linear function. Slope average rate of change exactly the same. Given 2 points, this is a formula. You need to memorize it. So find the average rate of change of this function on interval minus 3, minus 1. So what do? You're gonna find the 2 points first. I gave you x value, x value. I gave you 2 x values. So minus 3 is x value, minus 1 is x value. How do you find the y value given a function? Plug it in. Minus 3, plug it in for x. Minus 1, plug it in for x. When you do plug it in, make sure you use a parenthesis. So minus 3, you plug it in minus 3 here. So if you plug it in, you will get minus 3. Wow, they didn't do it, huh? So that's what, 9 minus 18 minus 12 plus 6. That's what, minus 30? It's minus 24. Okay, that is becoming minus 24. So once you plug it in, you can use your calculator if you have a calculator available. So you got y value as minus 24. So plug it in minus 1, just the way we did. Plug it in minus 1. So that's what, 1 minus 2 minus 4 plus 6. That's just 0. So once you plug in x value, you get 0 for y. So then you can label it as x1, y1, x2, y2. Then plug into the formula. So average rate of change formula is what? y2 minus y1 all over x2 minus x1. So plug it in. And if you have a graphing calculator, type into the calculator. If you don't, you just solve by hand. You do that, you get 12. Okay, when you do put that into the calculator, make sure you put parentheses on numerator, parentheses on denominator. Otherwise, I'm afraid you're gonna get wrong answer. Unless your calculator is smart enough, you can type that as a fraction form. Okay, use the data in the table value to find the average rate of change on interval 2 to 5. Again, all you have to do is find the 2 points. I gave you x value, I gave you x value. So 2, 5. I gave you x value, I gave you x value, find the y value. This is easier than previous question. Why? Y value is sitting right there. X value is 2, what's y value? 6. X value is 5, what's y value? Minus 24. Okay, that's x1, y1, x2, y2. Put that into the formula. So that will be what? y2 minus y1 all over x2 minus x1, y2 minus 24, 6 here, 5 and 2. Put that into the calculator. You get minus 10. Easy. Okay, Suppose the height of the object dropped from the roof of a 50 feet building is given by h of t equal to following, where t is time in second after the object is thrown. Find and interpret the average speed of the object for the time interval 0.5 through 1 second. Again, it sounds complicated. It's not. Average rate of change, average speed, average rate of change, exactly the same question. 0.5, 1 second. So you get 2 points. 0.5 is x value, 1 is x value. You have to find y value. How? Plug it in 0.5 for t, calculate it, y value. Plug it in t value as 1, calculate it, get the y value, which is h value. I did it already here. I did plug it in t here, I got the y. I plug it in t value here, I got the y. I use the formula y2 minus y1 all over x of 2 minus x of 1. Put that into the calculator, minus 24, final answer. Okay, a square with the side length of x is cut from each corner of the rectangle with dimensions 8 inches by 12 inches. Then the figures are folded to form an open box. As is shown in the diagram, determine the length and width of the box that will allow the maximum volume. Okay, so here is the board, I would say. You're gonna cut right here, you're gonna cut right here, square, cut, and you're gonna fold, so you'll form a box and top is open. And the situation will be something like this. Original board has a 12 by 8, 12 by 8. This is a 12, but if you cut x here, the remaining length will be 12 minus x, which is 12 minus 2x. Same thing. This width was 8 inches here, but you take x out, so this remaining width will be 8 minus x, which is 8 minus 2x. So you take this out, and you're gonna fold. You will form a box, something like this. Length, width, and the height will be this length, which is x. So that's the box. The question is, we want to maximize the volume. We want to maximize the volume. Well, volume of the rectangular prism, how do you calculate it? Length by width by height. You multiply this time, this. So volume can be expressed this time, this with parentheses. You need to graph this using graphing calculator, find the maximum using graphing calculator, then you got x equal to 1.57. So using graphing calculator, just you have to play with it. Once you graph it, your graphing calculator may not show entire picture. Then you have to play with the window. You might have to do zoom. So you will have to play with your calculator. So if I show you, I don't think many of you have TI-89. So you can use your computer software too if you don't have graphing calculator. So what I can just show you one. I'm gonna type the x times parentheses 12 minus 2x times 8 minus 2x. So that's my thing, and I'm gonna go to graph. I already adjust this, so let me go to my original graph standard, zoom standard. Okay, this is what I get without any adjustment. So I see something here, so I think like I need to do zoom out. I'm cutting off top, I'm cutting off on the bottom. So if you easily do zoom, so I can go zoom, I will do zoom out. And I'm kind of interested in maximum, so you can kind of go up a little bit. and I can do zoom. It's a little better, but it's still cut off. So you can do zoom more, zoom out. So I'm gonna move up my cursor, zoom out. Okay, the problem with this graph, it's too much squeezed left and right. So it's hard to look at it. Then I'll have to go window. So X mean, X max controls how wide left to right you need to look at. So it's a X mean is left, you're looking all the way to minus 160. I don't need to look at that left. I'm going to change to minus 10. X max is how far to the right. You're looking at 160. So you're looking at way too broad. So your graph is all squeezed. So I'm going to change it to 10. Then I'm going to graph it again. My graph looks a lot more nicer. You're not squeezing way too much. Then I can do a maximum. So my calculator have a math function here. Now I can choose a maximum. I click that. I click to the upper level boundary. Then my calculator gives you x value, y value for this maximum. That's how I got x value, y value for maximum. Because your calculator might have a different keystroke. If you're using a computer software, you can do find the maximum function, minimum function, similar pattern. Okay, so after all that, using graphing calculator, then you got maximum of this at x value as a 1.57. Okay, don't make a mistake. Oh, this is my answer. It's not, because the question is asking length and width. You need to find the length. You need to find the width. So length and width is defined using these expressions. So plug x value there, plug x value there, and these are the length and width. Okay, similar question. A glass candle holder is in a shape of the right circular cylinder that has a bottom and no top and a total surface area of 10 pi square inches. Determine the radius and height that will maximize the volume of the candle holder. This is a little challenging question. Why? Here's the situation. Here's a cylinder. There's no top. So if you cut it and spread, it will look like something like this. There's no top, only bottom. Area, surface area. So bottom portion will be, the circumference of this circle will match to this length. So when you fold it, put it there, this length should match to this length. So we have a rectangle. This is height, and this is width of this rectangle, but that width will be same as the circumference of this circle. So how do you define surface area of this situation? You need to calculate area of the circle. You need to calculate area of the rectangle. So area of circle pi r square plus area of rectangle, this times this, 2 pi r h. That's the surface area of this. If you look at the problem, they gave you value of surface area as a 10 pi. So I plugged in 10 pi as a surface area. Okay, here is the part we got. What do we want? We want volume to be as maximum as possible. So right there, you try to find, how do I find the volume of a cylinder? Area of the base multiplied by height. Area of the base, which is area of the circle, pi r squared times the height. That's the volume. Okay, right here I'm stuck. Why? I'm trying to maximize the volume. Look at the volume formula though. Your volume formula has two variables. You have R, you have H. You cannot deal with this if you have two unknown variables. You only should have R or H without the other variable. That's why we have this information. So you need to use substitution. Either you get rid of R here, you get rid of H. So you're trying to simplify this expression. I looked at it. I got pi, pi, pi everywhere. So I divide by pi everywhere. Then I looked at r. R has a square. I don't want to go there. So h is nice linear. So I'm going to solve for h. So move r squared to the left. I'm going to divide by 2r everywhere. I solved for h with this equation. Why? Because I'm going to substitute h here. So my volume formula will be expressed in terms of only one term. So I plugged h here with the parentheses. From there, it's all calculator. You graph this. When you graph it, I'm going to use x instead of r. So I'm going to graph this using x instead of r. Once you graph it, you do similar function of finding maximum, then your calculator will give you a maximum value, which is r equal to 1.83. R equal to 1.83, you can plug r value here, 1.83, to get the height, which is 1.82. And radius height, that will be your answer. Okay, so make sure you do the homework and join me for office hour for further question.